sudden. Super. Hands up if you can hear me at the back. Yay. Okay, so I'm going to spend the next 45 minutes talking about what it says in the title, why the project paradigm kills innovation and what to do instead. And if you want to skip the rest of the talk, I'm going to tell you what I'm going to say now so that you don't need to see it. Firstly, in conditions of uncertainty, which is exactly pretty much what innovation means, is we don't know what we're going to invent because otherwise it wouldn't be innovation, projects are unsuitable. Instead, what we should be doing is starting small and focusing on learning fast and changing what will undoubtedly be the bad idea we initially come up with. The most important thing to work out is how you're going to actually measure value and start doing that. And for those of us working in large organizations, hello? Ah. Well, it looks okay on this screen. And this is 4 by 3. So something mysterious is happening. Is there anything technical that can be done about this, technical people? Oh. All right, so everybody look at that monitor. Okay. For those of us who's working in an organization of more than 1,000 people, more than 1,000 people, lots of hands. Okay, then you need to worry about something called portfolio management, which is managing all the work you do at the very large scale. And we should be looking at measuring value using cost of delay at the portfolio level. And finally, I'm not really going to talk about this today, but this is kind of an advert for my talk tomorrow. Innovation is a mindset. And what you need to do to actually innovate is create a culture of innovation throughout the organization, starting with the leaders. So let's talk a bit about projects. Projects actually come from basically the US military-industrial complex, which when they decided they needed to build a new generation of bombs and big airplanes to blow things up and other things that involved lots of software in order to blow things up, they needed to actually develop software at a large and hitherto unknown scale. And what you saw in the late 60s was 2 conferences which were sponsored by NATO, which were about how to do this. And the term software engineering was invented at these NATO conferences, or first really kind of set out, I should say. I don't know if it was invented then, but they were first described in detail in these software engineering conferences sponsored by NATO. And projects essentially are designed for things which have the same characteristics as civil engineering projects, which is to say, we won't learn much in the course of actually building the thing that we didn't already know in the planning phase. They won't deliver any value until after we've finished building them. And once we've built them, they won't actually change very much. So once we've built them, then they're going to stay pretty much as they are. And in fact, the methods that we use to maintain them will be completely different from the methods we use to build them. None of these 3 things is true of software. Software, once we've built the first release, for any successful software project, is going to change substantially over its life cycle. In the course of building software, because building software is basically building a complex system, we discover a great deal that we didn't know in the planning phase. And finally, software projects can start delivering value long before they're complete in the sense of the entire set of specifications that we have in a typical project are actually completed. So for these 3 pretty simple reasons, projects are very unsuitable for delivering software innovation. And I'm just going to explore briefly some of the consequences of that. We actually saw, this is something that Martin talked about in his keynote yesterday, we saw in the 90s there was some discussion about whether or not the kind of typical project waterfall method was the right way to do things, and of course we all know what happened. We had the Agile Manifesto, and we decided there was a better way to deliver innovative software-based products. But what we see today is typically a process that I like to call water scrum fall. And water scrum fall is pretty much what happens at the enterprise level. We have the water bit, which Don Reinertsen calls the fuzzy front end, where basically Someone comes off the golf course and decides they have a fabulous new idea for a product, and we go through a study phase, and we get a business case, and then budget approval, and then somebody sits in a room and spends several weeks drawing large requirements documents and breaking them up into little bits. And then we estimate those things and do some further work on the budgeting. And finally, at the end of this, we actually start working on software. And there's, if you're lucky, there's this nice Scrum thing or some other iterative method where we're delivering in nice iterations. But actually, we're not really delivering because none of this stuff is, in fact, going into the hands of users. And what happens after this is we have integration and the testing phase. And in enterprises, who works in an organization where the software is tested by a different organization or by people in a completely different place? Okay, fabulous. So about a third of you. And then the whole thing actually has to be released to users. And if you're working on websites or software as a service or something like this, typically that's a pretty unpleasant time for the operations people who have to try and make the thing that works on people's development machines actually work in real life with real-sized data sets and realistic production hardware and real user load. So that bit from dev complete to released in production, live in production, is called the last mile. And my experience has been that it doesn't matter how agile the bit in the middle is. You can make that as agile as you want, but it makes no difference to the business outcomes and the customer outcomes if you leave the other bits the way they are. Two fun facts, which should help explain that, particularly about the fuzzy front end. Number one, we spend about 50% of project lead time in the fuzzy front end. What's the main activity we're doing in the fuzzy front end? A big part of it is estimation. And the reason we do estimation is to work out costs, to work out how much money we're going to have to spend to do this. There's a great book called How to Measure Anything by Douglas Hubbard, and he wrote an article for CIO magazine about 10 years ago which had this really memorable statement. Even in projects with very uncertain development costs, we haven't found that those costs have a significant information value for the investment decision. So in terms of actually whether or not we should spend the money, the development costs actually aren't that important. The important variables that have a high information value are whether the project will be cancelled and how fast people will start using it, and whether indeed they'll start using it at all. Those are the things that have high information value for an investment decision. And we typically don't measure those. And there's many projects that I've seen where we don't even measure the return on investment at the end. So in terms of actual kind of fiduciary duty and doing the right thing in terms of our investment, this is really, really sad and depressing. And my colleague, Ross Pettit, says that in many cases, we'd be better off taking the money we're going to invest in software development and putting it in unit trusts instead, because it would have a more reliable return on our investment. So let's return to the Agile Manifesto. The Agile Manifesto says that our highest priority, the first principle, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So apart from being a subliminal advert for my book, this poses an important question. What is valuable software? And the first thing, of course, is that value is something that belongs with an object. Value is value for someone. So we need to start by thinking about who is our software going to be valuable for? Who are our customers going to be? Now, I was once a product owner, and when I became a product owner, I basically read the stuff about Scrum and thought that Scrum would tell me what to do. And Scrum was pretty much useless at telling me what to do as a product owner. It told me that I should come up with a bunch of stories and prioritize and estimate those things. And I did loads of that. I was really good at coming up with stories, and I could prioritize them and estimate them, and I spent ages doing that. Well, not the estimation. The team did the estimation, sorry, just to be clear. But I kind of got them ready and helped the team to estimate them. And we did lots and lots of that. But I still, to this day, am not really sure about the extent to which we actually delivered valuable software, other than, in terms of our kind of overall bottom line, which is a leading indicator that's not very useful at telling you which of your features actually were valuable to your software, and just by, hearing people say nice things or otherwise about what we did. So after kind of as therapy, after I finished being a product owner, as a way to kind of recover from the trauma of that job, I started to look into what value was. So there's this concept of shareholder value. Shareholder value is very important in the US and other capitalist countries. The directors of a public corporation, in fact, have what's called a fiduciary duty to maximize profits. That means legally they're supposed to act in such a way that they maximize profits for their shareholders. However, research into competitive performance of organizations determines that the companies that place the highest priority on profit were universally less profitable than the firms that didn't. So the more you focus on this being your guiding principle, the less profitable you end up being. So it's actually a really poor strategy for, in fact, delivering customer value to shareholders. And in fact, the shareholder value model has presided over a decline in the rate of return on equity investment and capital. However, there has been someone who benefits from this model. There's been an 8-fold increase in CEO compensation from 1980 to 2000 as a result of people who follow this model. So somebody's winning, but it's not the shareholders. So let's look at some companies which do some interesting things around delivering value and look at some of what the foremost entrepreneurs of our time think about value. So in my opinion, one of the foremost entrepreneurs, well, let's start with Jack Welch. Jack Welch was CEO of GE, and he had this fabulous quote: "Shareholder value is the dumbest idea in the world. It's a result, not a strategy. Your main constituencies are your employees, your customers, and your products." And this, as with many things Jack Welch said, is pretty much spot on, I think. My number 2 entrepreneur of our times is a guy called Elon Musk. Who's heard of Elon Musk? Okay, a few of you. So Elon Musk founded PayPal, and when PayPal got sold to eBay, he had a ton of money. And he decided that what he wanted to do with this is send rockets to Mars. So he founded a company called SpaceX. SpaceX was the first private company to send a vehicle to the ISS. This is that vehicle. His mission for SpaceX looks like this. The company was founded in 2002 by Elon Musk to revolutionize space transportation and ultimately make it possible for people to live on other planets. Now, that's what I call a mission. This is a man whose stated goal is to retire on Mars. And he's pretty serious about it. I mean, from 2002, it took them 11 years to go from nothing to this vehicle, which was the first private vehicle to dock with the International Space Station. So that's pretty cool. But we don't all have to be Elon Musks in order to be entrepreneurs and to innovate. So I want to introduce you to this guy, Jack Andraker, who was the winner of the 2012 Intel Science Fair. He created a diagnostic tool for pancreatic cancer after his uncle died of pancreatic cancer. And he basically did this by researching things on Google and finding a local lab that would let him kind of play around. And he researched things like carbon nanotubes and various proteins and how to detect those proteins. And he came up with a way to detect a protein commonly used as a biomarker for pancreatic cancer using carbon nanotubes coated with antibodies that was 100 times more selective than existing diagnostic tests, 168 times faster, 26,000 times less expensive, and 400 times more sensitive. So this is a 16-year-old kid who was playing around with carbon nanotubes and various proteins and bits and pieces. I mean, that's pretty amazing, and quite rightly, he won this prize. So I have 2 kids. I'm pretty interested in how I can make my kids grow up to be like this guy. And so I was reading a bunch of articles about how he ended up doing this stuff, and I came across this quote which was fabulous. I'm like, well, what did his parents do? So his parents, he says, never really answered any of the questions that they had, him and his brothers and sisters. Go figure it out for yourself, they would say. I got really into the scientific method of developing a hypothesis and testing it and getting a result and going back to do it again. So that's a pretty interesting parenting method. Whenever your kids ask you a question, just say, go out, work it out for yourselves. I think that's something I can probably manage, in fact. But I think this thing is really interesting, this idea that It's the scientific method of developing hypotheses and testing and getting a result. And actually, Jack Andraker was one person who was pretty much the self-invented or self-developed entrepreneur. The chip that's in all the iPhone phones and many other phones is called an ARM chip. The ARM CPU was developed by 2 people in 18 months by these 2 people in Cambridge. And the guy who was in charge of the company, which is called Acorn Computers, he said, well, I gave these 2 people something that no other company gave them. I gave them no money and no people. They had to keep it simple. I think resource scarcity is actually really important to innovation. One of the ways we kill innovation is by investing a ton of money and spinning up a really big team and imagining that somehow that will enable us to finish more quickly. And in fact, the opposite is normally true. When you have a large number of people and you grow a team very, very rapidly, what happens is people start doing things and it all comes a bit uncontrolled, and the cost of communication massively overwhelms our ability to actually control the growth of what's happening and innovate in this way. And instead, we need to start small. And this is pretty much what the lean startup is about. So who's familiar with the lean startup? Hopefully most of you. There's a ton of talks about the lean startup at this conference, which can only be a good thing. But basically, the lean startup is just the scientific method. There's these fancy diagrams that you see everywhere in the kind of trendy colors of modern times, the kind of lime green and blue, which indicates that you should really believe the diagram. The build, measure, learn loop that most people, I'm sure, are familiar with. But really, it's just, a method that's hundreds of years old called the scientific method, which is that we create a hypothesis, and we design an experiment to test the hypothesis, and that experiment is called the minimum viable product, and we get feedback and we repeat. The thing is, people working in enterprises, they see that and this idea that we should start small and grow slowly and not do any of this stuff on financial management because that's kind of pointless, and certainly not spend months and months working out in detail what the requirements are and trying to get budget. And they often say, well, that's all very well, but it basically sounds like a load of crap. So I went on a holiday, the first holiday that I had after my kids were born without my kids, and in fact the only one to date that I've had without my kids. Me and my wife went to Barcelona for a weekend, and we saw this church called the Sagrada Familia. So anyone been to the Sagrada Familia? Okay, I mean, it's beautiful. It's designed by a guy called Gaudi, and it's been under construction for over 150 years. And it's still not finished yet. I mean, it's really a stunning piece of work. And Gaudi actually had a quote. People would ask him, well, it's taking a long time to build. And he would say, my client is not in a hurry. And Gaudi actually invented a number of new architectural techniques to build this church. A lot of people around the time this was built, most churches and large buildings were built using a perpendicular style. So people were very keen on corners. The kind of slightly wacky people would use arches, which of course were invented in the Islamic world a bit earlier. But in general, it was straight lines and arches if you wanted to push the boundaries a bit. And Gaudi was basically a bit of an awkward child, and he would go and play in nature a lot and look at how natural things, plants and so forth, were constructed. And he found these kind of hyperbolic patterns. And he started playing with the idea of parabolic structures and hyperbolic structures. And in fact, this is built, there's lots of hyperbolas in this church. If you go inside and look, it's modeled on how natural living things grow. The problem is he didn't want to just build it in this way because it's a bit risky when you build something with a completely new architectural style in case it falls down and kills everyone. And you really don't want that in a large building. And so what he did actually was experiment with, first of all, scale models. If you go down into the crypt of the church, what you can see is this is an upside-down model for an earlier, smaller church he built in the hyperbolic style. And what he did is he built this model upside down and hung these little weights to simulate the loads on the structure, and used this as kind of a low-tech way to simulate what the loads on the structure were to try and make sure that the thing would actually stand up. So he had all these techniques, low-cost experiments to try and determine if the basic premise would actually work and deliver the expected value, i.e. staying up. And he built lots of little scale models, and then he built a smaller church in this style, long before he built the Sagrada Familia. So this is just one example of where when you're doing something innovative, I mean, if you're building a truss bridge has known engineering qualities, and there's models that you can build that pretty much predict how the thing should be built in such a way that it will stay up, and you just punch the numbers into the model, and out comes, what the structure should look like and what the materials should be. When you're innovating in architecture, you actually need to use these small experimental techniques in order to work out whether the thing you're going to build is going to stay up. So this idea that even for civil engineering projects we shouldn't be doing innovation, we shouldn't be doing small experiments to test things before we hire tons of people to actually build it, that's not really true. And you can see that in this fabulous experiment that he did. The other example that people who are kind of technologically savvy like to give about why the whole kind of experimental approach is kind of crap is the iPhone. So this doesn't look much like a minimum viable product. I mean, when it emerged fully formed at the WWDC conference. I can't remember which one it was. But there was really no inkling that this thing would come out. It looked like it came out pretty much fully formed. Who knows what Apple's first product was? Anyone? Huh? The Lisa? No, there was a couple before the Lisa. It was that, anyone? Mouse? No, the mouse was actually designed as part of the Macintosh. The first computer Apple built was called the Apple I, and it was built in Steve Wozniak's shed in Palo Alto, and it looks a bit like this. This looks much more like a minimum viable product. And actually, the keyboard and the case were not supplied. You just got the logic board, and you had to get your own power supply and keyboard and so forth to actually make the thing work. And then if you look at the Macintosh, which was really the product that took them out of kind of geeks into the mainstream of design, the Apple Macintosh was actually built as a reaction to the Lisa. So the Lisa was built in a very traditional project manner where they had an enormous team of people, and it was very expensive to develop. And Steve Jobs got very frustrated with this process and left to create something which he actually was more passionate about, which is the Mac. And the Mac team was much smaller, and they worked in a very different way. And this is a quote from one of the people who worked on the Macintosh. He says, "Instead of arguing about new software ideas, we actually tried them out by writing quick prototypes, keeping the ideas that work best and discarding the others. We always had something running that represented our best thinking at the time." And this idea that we should always try something out and then integrate it all together and see what happens and see if we like it, that I think is very central to this idea of tinkering that's crucial to effective innovation. So I want to move on to this idea of measuring value and how do we measure value. There's actually a number of different ways to measure value. A/B testing is really powerful, and I'm going to talk about that in just a minute. There's very simple ways to do it as well, just showing people your prototype and seeing if they're interested in it, and crucially, if they'll actually pay money for it, is a very powerful way to measure value without actually building something. I mean, one of the problems with projects is the way we test whether or not our initial idea is valuable is we actually build the whole thing and then find out if it's valuable. That's the most inefficient way we can possibly test if the thing we're building is valuable. And there's much cheaper ways to do it, like showing people prototypes and seeing if they'll pay for them. Measuring business metrics. My favorite quote on value is from Donald Reinertson. He says, "The way the world tells you whether what you're doing is valuable is whether they send you money." And you should try and find that out quite early on rather than at the end. And really, we have this word requirements. I have a problem with the word requirements because whose requirements are they? Are they our users' requirements? Users don't know what they want. Users know what they don't want once you've built it for them. But they don't know what they want. The requirements are actually the requirements of what's called the HIPPO, the highly paid person's opinion. The person who's, the person who plays lots of golf and generally decides what the requirements should be. And I think if we're honest, we shouldn't be talking about requirements. We should be talking instead about hypotheses. There's this idea that a bunch of people in the Lean UX community have come up with of hypothesis-driven delivery. We believe, instead of stories, I mean, everyone's familiar with stories, right? As a, I want, so that, yay, right? We're familiar with the story format? Everyone written stories or used stories? Okay. So maybe instead of that, we should think about hypotheses. We believe that building this feature for these people will achieve this outcome. We'll know we're successful when we see this signal from the market. What's the signal from the market we're looking for that will actually demonstrate that the thing we plan to build is actually valuable? And can we find ways to measure that more cheaply and quickly than actually building the thing? So I want to show you what a company called Etsy does. Etsy does something called A/B testing. And A/B testing wasn't pioneered by Etsy. It was actually pioneered by the people who send you junk mail. They send you different versions of junk mail. They send different versions of the junk mail to different people and work out which version produces the highest response rate. And this idea was copied, basically, by software people who thought, well, instead of showing you just one version of a website, we'll show lots of slightly different versions and see which ones actually end up with people spending the most money or whatever you care about in terms of your goals as an organization. And so when Etsy develop a new feature, they don't build the whole feature out and then put it into production. What they do is find a way to build an experimental version of the feature, which is much cheaper. So we don't worry about making sure that it scales. We don't worry about covering all the corner cases. We find cheap, hacky ways to achieve the outcome without building the nice, elegant code that you would build for something that you actually really wanted to go into production. And they just switch it on the website for a small percentage of users. So this is a feature that Etsy ran an experiment on. It says, show similar items, link on unavailable items in the cart. This actually was a feature where, so Etsy is an online website that people, an online website, of course it's online, it's a website. Sorry. It's a website where people in the US who make handicrafts can sell their handicrafts to the general public. So anyone who has relatives in the US, it's a great place to buy presents for them. So this was an experiment where if you searched for a particular item and it wasn't in the person's shop who you were looking at, it would show you items from somebody else's storefront instead. And they turned this on for a small percentage of users first, and they built this fabulous tool that shows you what the impact is on the business metrics that you care about. So blue is the control group who sees the website without the experiment turned on, and green is the group of people who sees the website with the experiment turned on, which is a small percentage of users. And what they track is the business metrics they care about, the number of people who visit the cart, the number of people who bounce off the site, the number of pages that you get to see, and the number of visits that end up with something being added to the cart. And what you can see here, there's a very simple statistical model you can use to get this data. It's called the student T model. And what they look for is a 90% confidence interval in the statistics. And you can see here that this grayed out number means that we haven't reached statistical significance for this particular measure yet. But we have reached statistical significance for page count. And the improvement with the experiment turned on is 0.26% in the number of pages people visit on the site. And that's pretty average for an A/B test. A really good A/B test might give you a boost of 2 or 3%. Anything bigger than that is really surprising, and it probably means that your experiment was badly designed and you did something wrong. So that's the first thing to test. Now, as a product owner, this is like crack having this data. It's amazing. It's the coolest thing ever to be able to actually see a causal relationship between an experiment and the top line metrics we care about. And that's the great thing about A/B tests. It's not just a correlation, it shows you causation. This feature caused these improvements in business metrics. And you can get this data in a few days. I mean, and it doesn't take long to build the experimental feature because it's very, very cut down and simple. So it only takes you a few days to build, and then you can get the data before you invest the effort in actually building out the whole thing. So before they actually spin something up to really build out the feature, they get this data that proves the impacts on top-line metrics. And you don't need a lot of data actually to reduce uncertainty on what the value will be, because when the uncertainty is very big, the amount of data you need to reduce it is very small. So this is a very effective way to actually measure value before you go out and build out features. And they actually have a number of experiments running in production at any one time to try and gather this data. So you could end up, there's effectively many different versions of Etsy. And depending on which buckets you fall into for the various experiments, you could see any combination of these experiments turned on or off. Bing, which uses the same technique of A/B testing, there's about, I think, 10 to the 5 different versions of Bing because they have hundreds of experiments going on at any one time that you could possibly see. Now, experimental design is hard. Working out how to design experiments, make sure they don't interact, put the monitoring in place to actually detect if there's interaction or if there's regressions in other parts of the site, that's really hard. And it's something that actually is probably the most important thing you could possibly learn about product management, in my opinion. But it's something that, I mean, there's no talks on it at most conferences. It's something there's hardly any books on or literature on. For me, that's a real, I mean, unexplored territory in product management. It's how we actually do experimental design. And it's something I'd like to see people looking a lot more at. The guy who developed the A/B testing framework for Amazon and then went on to work at Bing, a guy called Ronnie Kohavi, gathered a lot of data from doing A/B tests. And there's a slide which I showed in Martin's keynote, but for those of you who weren't at Martin's keynote, I just want to show you again and re-emphasize this because it's pretty shocking. Evaluating well-designed and executed experiments that were designed to improve a key metric, only about 1/3 were successful at improving the key metric. So these kinds of experiments that we run, most of them demonstrate that the experiment delivers 0 or negative value to our customers. What that means is, if you generalize this, that means that 2/3 of the features that we build deliver 0 or negative value to our customers. We could be spending 2/3 of our time at home or on vacation in Goa on the beach and deliver the same value to our customers if only we knew the 2/3 of the features we build that have 0 or negative value. That's a pretty shocking statistic. Another way to quantify value at the portfolio level is to use what's called cost of delay. Cost of delay is a system that was developed, or popularized, I should say, by Don Reinertsen, where you basically think about how much it costs per unit of time, say per week, to not build the feature. And there was a fabulous paper that came out last year at the Agile conference by Josh Arnold and Özlem Yüce. And they did some work at Maersk, which is the world's biggest shipping company, on actually taking a number of requirements. They actually had 3,000 requirements in the backlog at Maersk, and they looked at all these different requirements and put together a team to actually put a dollar value on cost of delay for each of those features. So how much would it cost the company per month to not deliver that feature? And it took them a while to work out how to do it, but they got a bunch of people and got a bunch of estimates for that. And they plotted them on the graph. And what they worked out was that there was 3 features in the backlog that had a cost of delay of more than $1 million per week. So by not delivering those features, it was costing the company, $2 million for this one, about $2.3 million for this one, and $2.7 million for this one. And then all the other thousands of features in the backlog were right down here somewhere. Unless you actually go through this exercise, and it doesn't need to be very expensive, because again, we don't need much information to reduce uncertainty. Unless you're doing this exercise and actually looking at the value that your features deliver and thinking about it and trying to gather small amounts of data about it, the prioritization exercise is just going to be guided by whoever shouts the loudest and by politics. And actually, ThoughtWorks did a survey of how people measure value at the C level. And we actually worked, the data showed that most people actually use that method. I'm going to see if I can quickly get the graph for that actually, because I think it's worth looking at. Yeah, here we go. So this was the survey that we did. Please select the statement that most closely aligns with how your company decides which products are built. So the big blue 47% is decision by committee. The yellow one is financial modeling, which is actually using kind of real data and thinking about things from a financial point of view. 13% of people, the opinion of the person with the highest salary wins out. This is the hippo, the highly paid person's opinion. So Ronnie Kohavi, the guy who did the A/B testing framework for Amazon, actually has little rubber hippos that he gives out to people. So, say you're the hippo, here, have a hippo. But 13%, this is large companies. These are Fortune 500 companies. 161 business decision makers said 13% of them said the opinion of the person with the highest salary wins out. And then this blue 7% here is no systematic approach. And light gray is kind of product portfolio approach. So 76% of the companies surveyed basically weren't using any kind of economic model for doing prioritization of products. So the good news is there's a lot of room for improvement, although it's somewhat depressing that we're in this situation in 2014. I want to end just by reiterating the takeaways. When we spin up projects and spend all this time measuring cost and coming up with requirements, that takes, by the way, about 50% of our lead time to gather all this data, which isn't actually that important for the investment decision. That's a really great way to kill innovation. And products in general are unsuitable for building products in conditions of uncertainty. Instead, what we should do is use resource constraint and the experimental methods to learn rapidly about whether what we plan to do will deliver value. And in the normal case, overwhelmingly, they won't, to work out how to pivot rapidly and come up with something that will deliver value for our customers. The most important thing you can decide at the beginning of building a product is how you're going to measure the value that that product is supposed to deliver, and trying to find cheap ways to gather that data as quickly as possible. If you're working in an enterprise, the most important thing you can do to improve the outcomes for your enterprise is actually come up with an economic model for deciding how you're going to measure the value of things and using that to make prioritization decisions. And a great model for doing that is cost of delay, Don Reinertson's model. And then finally, again, an advert for tomorrow. Innovation is something that needs to be pervasive throughout the company. It's not something you can build in afterwards. It's something that has to be there from the leadership to the people on the ground. And the most important job of leaders and managers is to create conditions in which the people doing the work can work out how to measure value for themselves. So we've got about 7 minutes left. What questions do you have? Yes? So is it important for the development team to know how the product backlog is prioritized? I actually would go further than that. I think it's important for the development team to actually be designing the experiments. The job of leadership and management is to say what outcomes they want, what metrics they're actually interested in. And then it's the job of the development team to actually come up with the experiments to try out different ideas in order to drive those metrics. So, this idea that, deciding what features should be built is an upstream process that the developers aren't involved in, I think is fundamentally flawed. I think developers and analysts and product owners and UX people should be working together to design the experiments. Because actually experimental design is something that you need to understand software development in order to be able to do. The idea that you can design experiments, you can just have someone whose job is experimental design. I mean, you need people who understand about statistics and data, but you also need people who understand about how to build experiments cheaply. In other words, from a development perspective, what's going to be cheap to build? So development teams are instrumental in actually designing the experiments. And that, again, is very different from the traditional ideas about how we should do software development, and even most agile ideas about how we should do software development, which is the developers are passive receivers of stuff that other people have dreamed up. I mean, that's, in my opinion, fundamentally flawed. Yes?
How to measure the value of learning from failures?
How to measure the value of learning from failure? Well, I really recommend reading How to Measure Anything, because How to Measure Anything talks about, you can estimate the value of something, and you'll normally get a range. The value could be somewhere between here and here. And in that book, Hubbard talks about actually how you do estimation in this way, and you get a range. But then there's actually a mathematical way to calculate the reduction in uncertainty I mean, this is what a measurement is defined as. A measurement is defined as a reduction in uncertainty. And so if you calculate the cost of the measurement and the amount of the reduction in uncertainty, you can actually calculate how much money you should invest, or the upper limit to the amount of money you should invest in running an experiment to reduce your estimation of uncertainty. So using this kind of simple statistical and economic model, you can actually put real numbers on that data. I'm doing kind of a poor job of explaining it because I haven't got it in front of me, but it's all there in how to measure anything. I've actually got up here somewhere. Let's see if I can get it. This would be much easier if I had this in front of me. I'm not going to be able to get it up in time. But I recommend How to Measure Anything, because it talks about actually how much, you can see how much money you should invest in the experiments and get the upper limit based on the reduction in uncertainty. It's actually possible to calculate that mathematically. Yes? So the question is, how does strategy change the dynamics of the team?
Well, I'm saying it's a very
Greedy
greedy strategy.
strategy.
Right, numbers, curves. So the strategy, there could be a strategy at a layer that allows for different prioritization. Because that changing dynamics and giving us
I still don't really understand the question. Sorry? Yeah. Yeah. So, I mean, the role of strategy is basically to say what your goal as a company is, to make sure that everyone is aligned. So, I mean, the strategy is something like this. You know, our strategy is to revolutionize space transport and make it possible for people to live on other planets. So obviously you don't want things in your portfolio that don't contribute to that goal, right? But say you have a number of different things that contribute to that goal, you need to work out how you're going to measure the value of those things in terms of contribution to that goal. So yeah, I mean, you've got to have some end goal that you're aiming towards strategically, and then you have a bunch of different ideas as to things that could move towards that goal, and then you've got to prioritize them, and you've got to work out the value, and the value is going to be how far we move towards this goal. So there's definitely an interaction there. It's not that leadership is blind and it's just about numbers. There's got to be something driving this in the first place, absolutely.
So do you always measure value in terms of dollars?
No, absolutely not. Value is not about dollars, just about dollars. You can measure value in multiple different ways. I mean, for a non-profit, it might be, I mean, if it's vaccinations, it might be something like how many people we can vaccinate in a certain period of time. That might be, this is called the overall evaluation criteria. That's the role of strategy, to devise, or one of the goals of strategy is to devise the overall evaluation criteria by which you actually prioritize things. I think for Army logistics, Don Reinertson says it was cost per ton mile. That's what you're optimizing for. So that's why I say, at the beginning, my third takeaway is work out deciding how you're going to measure value in what we're actually going to use as our overall evaluation criteria in order to work out what to do. Okay, have we got any more time? 2 minutes. One more question? Okay, thanks very much, everyone.